Hi everyone. Let's solve an optimization problem involving a cost of a rectangular enclosure. We must build a rectangular enclosure divided into two equal sections by a fence parallel to one side of the rectangle. Before we read any further, let's draw this. We have our rectangular enclosure. And we know that our enclosure will be divided in the middle, dividing the enclosure into two equal parts. In fact, each section must have the area of 200 meters squared. We also know that the outer fencing costs $2 per meter, while the interior dividing fence costs $12 per meter. What dimensions of the enclosure will minimize the total cost of the fencing? We need to find the dimensions of the fence minimizing the total cost of the fencing. We also must determine the minimum total cost. Let's give names to the dimensions. Let's call one side of the enclosure by x. And because the other side is divided into two equal parts, let's call this part by y, and let's call this part by y as well. We must minimize the cost of the entire enclosure. How can we set up a formula for the cost of this enclosure? I know that this y will cost $2. This y will cost $2. This y will cost $2, and this y will also cost $2. So the cost of this side and this side and this side and this side is $2 times y, and there are 4 such sides, so I multiply it by 4. What about the cost of this side? Well, the cost of this side is also 2, and the cost of this side is also 2. So I have 2 times x, that is the cost of one such side, and I have 2 such sides, so I multiply it by 2. Finally, what is the cost of the middle side? The length of this side is x, and I know that this fence costs $12 per meter, which means that the cost of this fence will be however long this fence is, which is x, multiplied by 12. So I get plus 12 times x. I can simplify this equation. I get 8y plus 4x plus 12x. Altogether, I get 4x plus 12x. That gives me 16x plus 8y. This is what I want to minimize. I was also told that the area of each piece of my enclosure is 200 meters squared, which means that the constraint is that x times y is 200. I will use this constraint to rewrite my cost equation in terms of only one variable. Let me rewrite this so that I have y equals 200 divided by x, and I will take this y and plug it in to my equation for the cost. If I do that, I will get that cost of my enclosure is 16x plus 8 times whatever y was, and y was 200 divided by x. I can simplify this a bit, and I will get 16x plus 1600 divided by x. 200 by 8, 200 multiplied by 8 is 1600. This is my equation for the cost. Let's give it a name. F of x equals 16x minus, or rather plus, 1600 divided by x. I take the derivative to find critical numbers, and I get 16 minus 1600 divided by x squared. Remember, x cannot be negative. The only x's I'm allowed to use here are positive. The domain of this function are all the x's greater than 0. Now I ask myself, is it possible for this derivative to not exist? And is it possible for this derivative to equal 0? There is one x for which this derivative doesn't exist. It is x equal to 0. However, x equal to 0 is not in the domain of my function. Also, x equal to 0 makes no physical sense. I will not take it into consideration. To determine when this derivative equals to 0, I set the derivative equal to 0. And I get 16 minus 1600 divided by x squared equals 0. I move the fraction to the right side, and I get that 16 equals 1600 divided by x squared. Multiply both sides by x squared, and I get 16x squared equals 1600. Divide both sides by 16, and you get that x squared equals 100. Take a square root, and you get that x equals plus or minus 10. The only critical number out of these two that makes sense is x equal to 10. X equal to negative 10 is not even a critical number because it is not in the domain of our function. X equal to 10 is the only critical number I take into consideration. That's the one that makes physical sense. Does x equal to 10 give me a max or a min? Let's use the second derivative test. I take my first derivative, and I take the derivative of that derivative. When I do that, the second derivative is plus 3200 divided by x to the third power. I believe the second derivative is always positive for x is greater than 0. This means that f is always concave up for x is greater than 0, which tells you that x equal to 10 gives you an absolute, gives the absolute minimum. And that is because the function is always concave up, giving you absolute minimum. When x is 10, what is y? We were given an equation for y. We knew that y equals 200 divided by x. When I divide it by 10, I will get 20, which means that y is 20. We know that x that minimizes the cost is 10, y that minimizes the cost is 20. Both of these are given in meters. Remember, the dimensions of the enclosure are x and 2y, meaning that our answer is x equal to 10 meters, 2y equals to 40 meters. These are the dimensions that will minimize the cost of the enclosure. What is that minimum cost? Thankfully, we have a formula for the minimum cost. The formula is 16x plus 8y. Let's plug in x equal to 10, y equal to 20, and see what we get. Minimum cost is 16 times 10 plus 8 times 20. That gives me 160 plus 160, which gives me 320. The cost was given in dollars. The minimum cost is $320.